Hi there, we're talking about speed time graphs today. Now, on my video on speed, distance and time, I covered distance time graphs. Now in this video I'm going to start talking about speed time graphs. So you can see on this graph here, it shows how speed changes over time. Now you can see here that as time ticks on, our speed doesn't go up and it doesn't go down. So we're talking about a constant speed here. Now can you tell me, can you remember what this horizontal line on a distance time graph would have shown? Well, on a distance time graph, it would have shown stationary, not moving. So the same line on a speed time graph means a different thing to what it means on a distance time graph. So you must look at this axis label here very, very carefully to make sure you don't get them mixed up. How would you describe the motion here from this line? Well, the speed is increasing as time ticks on. Can we say anything else though? Well, we can say that it's a straight line, which means that it's increasing at a constant rate. The speed is increasing at a constant rate. What that means is each second, whatever this is, this object is increasing its speed by the same amount. We've got a negative correlation here, so the speed is dropping down to zero. We've got a constant deceleration down to zero with time. And that's really it. If you had a curved line, what would that show? Well, a curved line is an increasing gradient, and what that would show is not a constant rate of acceleration but an increasing rate of acceleration. So those are the sorts of lines that you're going to see on speed time graphs, and really just the take-home message is don't get them mixed up with distance time graphs. So compare and contrast the motion of these two objects. Well, first of all, we'll compare. Compare means say how they're the same. So how are these two lines the same? Well, they both show an increase in speed with time. They're both straight, so they both show a constant rate of increase. Now let's contrast. How are they different? Well, B is a steeper line. So what does that mean? Well, the steeper line, the faster it's going, the faster its increase in speed, the faster it's accelerating. They've both got constant acceleration, but this one's constant acceleration is faster or higher than this one's constant acceleration. So the slope of the line is the more steep the line is, I should say, the faster the acceleration. We've got a deceleration here, and again we've got a very steep line and a less steep line. So D, this line here, is the most rapid deceleration. It started at the same point, and you can see that this one's going to reach zero faster than this one. So steeper line means faster acceleration or faster deceleration. And a curve, like I said, a curve is just an increasing steepness of line. So a curve means an increasing rate of acceleration. Now, the area underneath the line represents the distance travelled. So we've got speed in meters per second here, we've got time here, and if you want the distance, it's the area underneath the line. How do we calculate the area under the line? Well, let's go through a little exam question. What distance was covered in the first 10 seconds? Well, in the first 10 seconds, we have to work out the area of this triangle here. And the way we do that is by working out the area of this rectangle and dividing it by 2, because the area of the triangle is half of the area of the rectangle. So that's easy enough. 20 multiplied by 10, that gives us the area of the rectangle, and then you divide that by 2 to get the area of the triangle. And our answer is 100 meters. So this line shows that an object has travelled 100 meters. And I know it's meters because the speed units show meters per second. We've already got a unit for distance here, and it says meters per second, so we have to use meters in our answer. Let's finish up by calculating acceleration by finding the gradient of the line. Now, the gradient of line is the distance on the y-axis divided by the distance on the x-axis. Or, to put it another way, the rise over the run. Here's our rise of 20, and here's our run of 10. So 20 divided by 10. How many 10s do you get in 20? You get 2 10s in 20, so that's 2 meters per second squared. So our acceleration is 2 meters per second squared. Now, meters per second squared is a strange unit. What's this square all about? Well, I'll explain that in the next video we do on acceleration. So that's it for speed time graphs. You can test your understanding here with a few questions. Pause the video now, work out the answers, and on the next slide you'll see the answers and you can check your workings. So there we go, that's speed time graphs. Do leave comments, give me some feedback, like, subscribe, that sort of thing. Thank you very much for watching any of these videos. Good luck.